This is Sniper Team Django, and we did the GE Precision Launcher. In this presentation, we will outline the creation of our launcher with the engineering design cycle. The slides are divided into Ask, Imagine, Plan, Create, and Improve. Finally, we discuss what we learned and end with a conclusion. The objective was to design and build a projectile launcher to strike a target 30 feet away. The challenge was that the only potential energy was a 5-pound weight that could be dropped from no more than 4 feet, and the system must contain at least 2 methods of energy transfer. 4 major questions arose. The first was the basic design. Did we want to use springs, air compression, rubber bands, or a simple trebuchet? The next question was about the projectile. What size, shape, and weight did we want to use for it? After that, we needed to figure out how to fit in the 2 required methods of energy transfer. Finally, we had to devise a consistent release mechanism. These were our very first designs. They included the trebuchet with compressed air on the left and the crossbow with the springs on the right, followed by the crossbow that instead used surgical tubing. Our final decision combined previous designs using pulleys and surgical tubing and a crossbow. We've asked the questions and imagined a design. The next step in the design cycle is planning. We needed to divide tasks between members, acquire materials, and set a timeline to finish the project. After debate, we decided that the best basic design would resemble a slingshot and use latex bands. We chose a stress ball due to its aerodynamic properties and soft impact. We decided that pulleys would efficiently transfer energy. Gravity pulls down on the weight, which pulls the piston attached to the bands, and then releases, launching the ball. For the release mechanism, we fashioned a hook from a clothes hanger. The hook would be attached to the piston, and once the hook is pulled back far enough, it hits the nail and slips off the piston, releasing it. This is a list of materials we needed. They included PVC, latex bands, a car jack for adjustment, a soup can for the piston, pulleys, and
wood for days.
This is our final design once we finish building.
3, 2, 1, go. Nothing. Oh, yeah. Damn.
Ah.
Go.
Ready.
3, 2, 1.
Why is it doing that?
That one just.
What the?
While creating and testing the launcher, we found that it needed many improvements. We found that the latex bands were more convenient than springs or surgical tubing. After talking to Miss Queen, we added the car jack to make the launch angle adjustable. Rope was superior to floss and fishing line when regarding the pulleys. The soup can was both lightweight and sturdy, unlike the PVC piston and Pringles can. On the release mechanism, we combined using a pencil and carabiner with a nail and wood apparatus for consistent releases. We learned many important aspects regarding teamwork and engineering during this project. Communication was paramount. Texting teammates concerning meeting times, as well as simply checking progress, made the process run smoothly. We were working under a time constraint and always had a deadline. Time management was key in seeing that our project was completed on time. The project was a daunting task and would not be easy to do alone. The division of tasks was a necessary component to evenly divide the workload as well as minimize the amount of time one person had to spend on the launcher. Each team member could complete certain tasks more efficiently than another, as well as complementary skills. Recognizing and utilizing these strengths maximized the effectiveness of the final product. The launcher lost power as we continued trials. We realized that we should have reinforced the main posts that were attached to the weight and latex bands to minimize energy loss from excess vibrations. We switched to different materials from those originally intended for a variety of reasons. Using a soup can instead of the Pringles can, or rope instead of fishing line vastly improved the efficiency of the launcher. Trial and error was by far the largest component of the Precision Launcher project. For everything that went right, something else went wrong. The latex bands could be stretched and tied to various degrees, and in turn yielded various results when it came to launching. Also, repeated use of the bands caused them to lose their tension, again hurting the launch results. The weight could be dropped from a maximum of 4 feet. We wanted to give the weight a bit of slack so that it had some velocity before it started putting force on the pulleys. We were constantly readjusting the weight to find the right amount of slack and the best points to drop it from. The hook we fashioned from a clothes hanger gave us trouble because it would not release consistently. Every launch caused a slight bend of the hook, so after every few launches we had to readjust the hook, and it was difficult to pin it back to exactly how it was before. The hook also had a tendency to slip under the release partition. Redesigning the release mechanism and making the hook release from the side eliminated the issue of the hook slipping and bending as much. In conclusion, we outlined the making of our launcher with the 5 steps of the engineering design cycle. Ask, imagine, plan, create, and improve. The team worked very well together. We completed our task in time and also managed to achieve 3rd place in the Fed competition. Who are we? STD, burn some heat!
And they stay there.